So, we've talked about coin flips a few times in this class already, and hopefully, by this point, you know how these things work. You've got a 50-50 chance, a 1-to-1 set of odds, so you want to talk about it, between the results of getting heads or tails. Where, with these coin flips, this isn't a magic coin, and no matter how many times I flip it, no matter how I flip it, how I catch it for that matter, each flip isn't going to affect the next one. If I get 10 coin flips in a row that happen to all be tails, that doesn't mean I'm more likely to get heads on the next one or more likely to get tails because there's a streak going and you can't break a streak.
Getting a bit of a bore, isn't it?
A bore?
Well,
What about the suspense?
what suspense?
Each one's the exact same probability as the last one. Nothing changes, nothing adjusts how these things work. And talking about whether or not there is some effect there gets into a thing called the gambler's fallacy, but we're not going to worry about that too much in this class. The point is, when I flip my coin, no matter how many times I do it, no matter how many heads I get, how many tails I get, how many times it lands on its side for that matter, it doesn't make any other result more or less likely for what happened previously. So each of these coin flips is an independent event as compared to the others. That's what we call a pair of events, or a set of events, however many we need, is independent if there is no direct connection, no cause and effect relationship between the events. For that matter, if I flipped my coin and I got heads, then I pulled a card from my deck of cards that I don't have in my hands right now, and I got a jack, the cards, presuming I'm not doing anything too clever with magic in that kind of drawing, aren't going to be affected at all by what happens with the coin. And the coin is not more or less likely to land heads based on what happens with the cards either. They are completely separate from each other, so we say those two events are independent. And for that matter, if there was some sort of effect, if there was any sort of connection at all, we would then have to say instead that the events are dependent, where any situation in which the likelihood of one thing changes the likelihood of another, that is, one thing happening makes another more or less likely, we say they are dependent. Where in the real world, dependence, I'm not going to say it's more common, but if it isn't immediately obvious that two events are independent, there's a good chance they're going to be dependent in some way. It's kind of funky saying that sort of thing because dependence is kind of a one-way street usually, but we'll see how that looks with a few examples here to help build this idea a little bit better than just my coin did. So for this, we want to determine if the following events are dependent or independent, where for our first case, we are selecting a queen, then not replacing it and selecting a king. For our second, we are tossing a coin, getting a head, then rolling a six-sided die and getting a 6. Then we are driving over 85 miles per hour and getting in a car accident. In that first case, there's a very important word that we should focus on, or very important little phrase that we should focus on, which is not replacing it, or as we'll see elsewhere, without replacement. Because when you draw the king, we had 4 out of 52. But when you're going to draw the queen, we would still have 4 queens left because, well, there are not any king queens. But we would have 51 remaining cards. So in this case, the probability of drawing a queen, given that you have drawn a king, which is a special notation that we'll talk about later in terms of conditioning, is slightly higher. That is, the probability of the second event has changed a little bit based on the first one. So we would say in that case that B depends on A. Where, again, there's a little bit of that speciality, a little bit of that directional nature to looking at dependence of events that we want to be a little bit careful of here. And by the way, this idea that certain things in a deck of cards are more likely if other things have already happened is essential to the idea of counting cards, but that's a topic for a different class. Anyway, for our second case, if you want to look at what happens there with the coin toss, hopefully we can tell that no matter what happens with the coin,
Call it.
The coin don't have no say. It's just you.
The probability of getting the 6 is 1 out of 6. There's a 1 to 5 set of odds there for the die.
I got here the same way the coin did.
And the coin is the coin is the coin is the coin, just like we said. So these events are independent. And then finally, for our third case, well, this is a matter of, I guess you could say your confidence, your ability behind the wheel, how you feel about driving, if you feel about other people driving for that matter. But when you're driving very fast, maybe you're more conscious, maybe you're more careful, maybe you're not. Point is, the faster you go, well, the accident is either more or less likely based on speeding, because, well, you're either going to be driving better or you're going to be driving worse. Point is, it's changed. So these are dependent. That is, the probability of being in an accident depends on how fast you're going. So that's our rough idea here for what it means to be dependent versus independent. Let's actually talk about defining some of these probabilities here. First, looking at the nicer case where things are independent.